Welcome back to the Jill and Jason Update. This is week 10 of the Combat Vehicle Robotics Engineering Evaluation Test 2. We're up here at Camp Grayling, and this week we have the crew optimization and augmentation technologies. And you know what they're really focused on is optimizing the entire crew within that command and control vehicle.
Awesome thing about having COAT at the Cover EET2 is that they're taking the robotic operators and the manned vehicle operators, putting them in the same platform, comparing them on the same baseline. So we're going to get great data and it's going to speak for itself.
And you know what we're really excited for is really giving the option of what the crew stations could look like.
Stay tuned after the credits for a special guest.
First of all, COAT stands for Crew Optimization and Augmentation Technologies. We're a science and technology project under the Next Generation Combat Vehicle portfolio. And what we're doing is we're developing software such as interfaces, interaction protocols, and decision support tools to enable coordinated platoon level maneuver for mixed manned-unmanned formations.
So we're taking a vehicle crew and we want to optimize their performance as well as augment their performance. The GVR Cover folks are developing new autonomous technologies. So we're looking at how do we take those autonomous technologies and how do they team with humans? Because there's certain tasks that humans are good at and there are other tasks that robots are good at, and we want to figure out what's the best way that they can team. So we're looking at workload. How do you dynamically share tasks, like the driving task, right? The way the Army works right now, the driver's the driver. That's his job. He always knows his job. If we want to share that with autonomy, right? Like autonomy can drive some of the time. What does that guy do? Well, he's not driving. When does the driver know that he needs to regain responsibility of the driving task? That's just one example, right? All the roles and all the tasks. So how can you switch in between those roles and do that effectively is the high-level problem that the COAT program is trying to address, and it's not an easy problem to solve.
We're having the test subjects drive through 8 different courses, and so each one of those courses is looking at a different driving function, and so in total we'll be able to have a really good idea of how the subjects perform using the helmet-mounted displays versus the vehicle-mounted displays.
These are very small, very tight, standardized courses to really impress upon a specific element of maneuver. We've got a very simple one where the operators maneuver down a road. We have a minefield course where the operators are asked to maneuver their vehicles through a very tight passageway. We have a slalom course where they zigzag in between obstacles. A mogul course where they experience roll motion. Formation change course where we ask them to change formation from line to column, column to line, and line to inverted V. We have a berm drill exercise and 2 urban courses. One where it's a simple urban driving scenario, and one in which they have to peek out from behind buildings and align their vehicles as if they're going to target an enemy off to their flank. Those are all the different types of maneuver operations that we're trying to sort of hone in on and see if the technologies that we're testing enable the operators to perform those actions better.
What we're doing is we're comparing 2 types of interfaces. One is our traditional interface that we use called the warfighter machine interface, which is on our vehicle mounted displays. And then we have a new interface that we've developed for helmet mounted displays. And so what we're doing is we're testing driving performance using both of those displays and just kind of comparing and contrasting how the test subjects in a section perform between helmet mounted displays versus vehicle mounted displays.
All of this is new. With the WMI and the vehicle mounted displays, tele-op driving a vehicle, which involves vehicle mounted displays, which if you've been in one of these vehicles, they're cram-packed full of displays. What you want to do is replicate the outside world from within your vehicle. So you have cameras pointing in all directions. Wherever a camera is pointing, you want a display pointing in that direction. For motion sickness abatement and things like that, in order to maintain what we call unity vision in what you see and what you're being given through the cameras, it involves a cluster of displays, solid mounted, vehicle mounted displays. An advantage of the helmet mounted displays is you can take all that physical hardware and the volume that it takes and isolate that down to one helmet mounted display, one small unit, which just the soldier has. So you've taken all the, expense, if the expense is the issue, but the volume and complexity of all these displays and shrunk it down into a much, much smaller unit.
As the project lead, one of the greatest benefits of being the lead is our collaborations with different organizations, industry partners, academia, as well as other centers within the Combat Capabilities Development Command. We have a really good partnership with the Army Research Laboratory, specifically the Human Autonomy Teaming Essential Research Program, as well as the Soldier Center as well too. They're helping us with training aspects for human augmentation. And so those collaborations have been great. It's always wonderful to work with researchers that are very capable, very interested and passionate about these very complex problems. I'm really excited to see where this goes. I think we have really great technologies coming into the crew station and a really great future up.
Thanks for tuning in to the Jill and Jason Update.
Catch us next week for DARPA's Assured Autonomy at the Cover EET 2.
All right, so next week's video, what should our focus be?
I don't know, let's circle the wagons and drill down. Hey Jeff, you pass the cream?
Finally, something I can do. See y'all soon.